Hello, welcome to the Allegis bi-weekly learning sessions. My name is Tom Fanero, and I will be presenting on agentic architecture and workflows this week. And want to actually review here the overall agenda or content of the presentation. We will be discussing the objective of this learning session, of course. We will be talking a bit of AI and some terms that are very, very important to define from the beginning. We'll be talking about design and the need for really strong domain-driven design before we build agentic workflows or agentic architectures. And then we'll be talking specifically about different types of workflows involved in that process. And then finally, the architecture that's developed to support the system. Then we will start moving towards the actual software discussion of tools that are needed, as well as we'll take a look at the code, and then we'll do a live demo. Before I go further, I'd like to thank Allegis. This is the product of open source work with the CNCF Dapper initiative that I did over the last 3 months with the support of Allegis. And so I'm presenting it here to take that learning and discovery and inform those of us who are interested in this kind of technology at this point. So the objective, obviously, is to learn the basics of agentic architecture at Allegis and how to best apply it. We do have an AI task force which has established the legal aspects and security aspects of using such technologies, and also the beginnings of technology standards, and we'll learn about some of them here. We've established the Azure AI Foundry as a framework of technologies that we can actually use and feel confident and secure about them. And we're also seeking to definitely work with our AI roadmap and our R&D and POC pursuits that we have actually going on as part of fiscal year 26. So before we go any further, I'd like to talk a bit about AI itself and some important terms. Obviously, agent is an important term, and an agent is an AI service that acts on behalf of a domain, person, or thing. So AI agents, particularly involved in an agentic architecture or a multi-agent architecture, can represent many things, and we'll see how that's demonstrated further on in the presentation. An interesting programming paradigm. It's been around since the 1990s, but is now getting updated in reference to the age of neural networks and large learning models, language models that we have. And it's a programming paradigm that orchestrates non-determinism and determinism in the form of prompt engineering. And we'll see that as a subset of object-oriented programming, or actually object-oriented programming is a subset of agent-oriented programming, depending on your perspective. There are tools out in the market that you can build agentic architectures, Crew AI being one of them, and where they have a templated approach to building different industry agentic networks of typical crews that are involved in a particular industry, whether it's construction, insurance, financial, what have you, healthcare. You have Microsoft's AutoGen, a very, very limited approach to building agents in a network, and that is actually being quickly absorbed into the Azure AI frameworks and technologies. And then Dapper Agents is coming out, another CNCF initiative by the folks at Dapper. So before I go on any further, I'd like to actually discuss, I think, some values here, which are important. We know that at Legis we have values, and we want to actually create value for our partners here. And we're, obviously partner first, and we want to assist them. So we want to use this technology for that. I don't think we want to be seeking to replace jobs or anytime soon. Even within our own company, I think we definitely want to stay. We'd like to stay on the creative and the assisted side of that, and we always want to. We want to have people first, and we want to always be pushing forward. So I think AI can fit our values very well. RAG, or RAG as it's known, is retrieval augmented generation from APIs, database queries, document corpuses, or groups of documents, and of course trained LLMs. So an ability to prevent LLMs like ChatGPT to hallucinate by asking it a non-deterministic question and having to come back with all kinds of hallucinated information. We can use RAG to retrieve information and augment that information with our enterprise information through much more specific information to prevent that hallucinating and cause more value. Where can agents live? A lot of places: chatbots, web apps, job schedulers, edge computing, of course, even in your vacuum cleaner. Okay, enough can't be said about good design in reference to modernizing a company, particularly with microservices, on top of building an agent architecture, a network of agents working together. As you can see, I've chosen a fictitious company called ABC Wholesale to model here in a domain-driven design context map. And you can see the various core domains, support domains, generic domains, their relationships to each other, upstream and downstream, their political relationships, and their relationship to generic domains such as Workday and Salesforce that we have here. And what's very important is the little checkboxes that we see next to each domain, which are the business rules. And identifying those business rules and that business logic specific to those domains are very, very important, particularly to AI agents, because AI agents have to follow that domain awareness that occurs there. So enough can't be said about, first of all, doing good design before we engineer anything. Okay, so you really can't talk about agentic architectures unless you start talking about workflows and the various workflow patterns fit nicely into working with agentic architectures, and they also particularly, when implemented with a particular workflow technology like Dapper, the causation of great resiliency, which is really, really necessary, as we'll see later on in our presentation. What I have on the screen now is a routing slip pattern. And years back, we used to actually literally route by paper a routing slip envelope through a company to collect information. We're never really sure if it would ever return, if somebody went on vacation, but it was routed back to administration and then usually given back to the executive level for kind of an aggregated reporting output. And the agentic architectures make great applications for that. They work 24/7, so you can send out a routing slip at any time that you want, and the reliability should be very, very good, and you get it back in a matter of seconds, which has never been really, we've never been really capable of doing that before. There's another design pattern, which I call the delegation pattern, where a management agent, depicted here in the middle, will analyze a user's prompt and determine what domains it actually has to contact in order to get information. It will contact them. They perhaps can also contact each other via the use of what's called a virtual actor. We'll talk about that in some future presentations. And the information then is given back to the routing manager for review and then sent back to the user. So this is actually a very common pattern too, and we'll actually see that further in the presentation. Last but not least is the architecture, of course. And we are using a microservices architecture to articulate the domains that we had looked at earlier under design. And as you can see, there's the respective domains and their constituent microservice or micro agent. Within the microservice has its respective, they have their own respective data sources. And obviously, as we talked about before, business rules. So microservices architecture works very, very well for agentic architectures as well. And we'll go under the hood a little bit more and look at the code that implements those microservices. Okay, so some basic technology here to share. I am using .NET Core C#. I'm using Visual Studio 2022 Community. You can also use VS Code, no problem. And using Dapper 1.14 for the workflow technology. You'll need Docker, obviously, for the Dapper containers. And you can also use Podman as well. I'm staying in the confines of the Azure AI Foundry using Semantic Kernel and some other tool sets. And what's interesting is I am using Ollama to run LLMs locally. As you can see, there's probably over 25 different LLMs that you can run locally with Ollama. The beauty of it is it's secure. You can actually run them without being connected to the internet. And they are reduced versions of the models that are out there, out in the cloud. And if you've got the right hardware, you can run them well locally. I'm running on a Qualcomm Snapdragon processor on a Windows Surface laptop, really, really neat device. It's 12 core, 3.40 gigahertz processor. And you can run this on any Intel or AMD based processor, 10 to 20 core CPUs. What is an absolute must is to run them on 32 gigabytes minimum RAM. That is an absolute requirement there. Okay, so we're going to go run a live demo here. We're going to do some interesting things. We are going to prompt our network with a user prompt asking it to send us some information via a routing slip. Please send current employees and sales. And we'll see if it can do some correlation for us there. So we send the message into the network, and it should contact the management agent. The management agent in the workflow, as depicted here, is now assessing what domains actually will get the routing slip. And so we should see shortly that it should start with because we actually are looking for new employees. It's going to contact HR accounting, and then obviously it will skip inventory and go to sales. And as we can see here, it is still working on that. Now it's getting the employee information. And as we look at the Chloe is the manager at HR. She just got her prompt, and we've got a little bit of a meta prompt there saying that she's friendly and efficient. As you can see, she is. She actually gave us the information already. It should now be contacting Carlos in sales. And look at Carlos go. He's very friendly, but also efficient as well. And he's given us our sales information. So now that information will be aggregated, sent back to management for review. As you can see, it's keeping the user informed of where it's actually going. These applications do not necessarily have to run in a chat. They can run as part of a web application. They can run as part of a batch job or scheduled job. So they can actually run in many different types of implementations. So DeepSeek, which is actually being used as the LLM here for the overall aggregation, has finished. Sent us back the information, and as you noticed, it's told us that Alice, Bobby, and Carol are our new employees. It's actually correlated the sales to them, and telling us that we've got a total of $780,000 of sales. Great job. Thank you for that. We have our various avatars up here, and that was Jimmy and Janice there that actually work in management. As you can see, there's Chloe, Jenny, and Carlos. Okay, so now we're going to switch to the actual other pattern, which is just communicating to a particular domain, and I'm going to actually ask for inventory. Please send inventory. And now it will invoke the delegation pattern, which I have here, and management will then review the request and route it to the specific domain or agent, and in this case, obviously, it will be Jenny in inventory, and if Jenny needs to, she can reach out also to any of the other agents by a virtual actor, which is a pattern we'll discuss in a subsequent presentation. And we'll go back to the actual, we should see Jenny get her prompt. Yeah, Jenny did get her prompt. She's actually sent it back to management, and we will see that the information, which now is being aggregated and reviewed by DeepSeek via the management agent, and it should return our inventory shortly here. Okay, so management is reviewing information. That means that Jenny sent it back already, and we should see our results shortly. If you notice here also on the top, I have thumbs up and thumbs down, and that means you can reward or punish the results as they come back, and that can be used for further processing to train an LLM in terms of what is quality information that we're getting from our system. So as you notice, it's returned the inventory very, very nicely there, and we'll just exit out. Okay, and obviously it said nicely goodbye. I actually want to try one more thing here. Let's actually go back to the team chat, and let's go back and get inventory one more time. And this time I'm going to actually crash the system. And so we can test out resiliency. So another user somewhere typing in the actual same message somewhere, and we should see shortly that agent is getting the information again, and we should see Jenny get prompted in the background there. And what I am actually going to do is actually crash the system. Okay, Jenny's getting the information. Okay, she's returned it, so it's going to go back to management now for review. And we just wait a few seconds here for that to happen. And while that's actually happening, I'm going to crash the system, and we will see it will actually gracefully recover. So I'm going to go back to Visual Studio here, I'm just going to shut these micro agents down over here. I'm going to shut off the workflow. Somebody turned off the power at the data center. Oh no, what are we going to do? Well, no problem. I think they'll turn the power back on, and our applications will automatically start back up again. As you can see, the workflow starting back up. It's checking the state store and recovering where we left off and doing a replay. And as you can see there in the blue, it actually still remembers what we did, so never fear. And we should see our results return as the system recovers. Okay, there it is. Basically the same answer. Thank you very much for that. Okay, you can imagine if you have 1,000 users on the system and the system crashes, we're going to have a lot of unhappy customers. So it needs to be an enterprise grade system using resilient workflows. Okay, so I'm going to go under the hood here a little bit and look at our actual microservices. If you notice, each microservice reflects its constituent domain: accounting, inventory, management, notifications, and sales. And we'll look at accounting here, and we'll see that accounting is built in the fashion of a vertical slice architecture. And under the features section, we have a micro agent. And that micro agent actually adopts the DNA of that particular domain and has its own anatomy in the new model called AOP, Agent-Oriented Programming. It has its own API that it talks to the world with. It has its own memories, it has its own personas, and it also has its own plugins. And what's interesting about the plugins is that they are actually object-oriented functions, but they're not actually part of a classic, POCO object, a plain old class object. They are just a list of functions, and the micro agent knows by inference or semantically actually how to call those. So we could have a whole dictionary of those functions for it to call them based on the user prompt. It knows almost intuitively which one to call. We don't have to actually write object-oriented code to actually do that. Okay, and then so that's the accounting API, and I think we need to look at the workflow, which is doing a lot of the work here. Obviously, it's written in Dapper workflows, which articulate very, very easily, just a series of workflow patterns that we have here in classes with their associated activities. And we don't have to go deeply into that, but we can see in the what I call the results rewrite how we're actually using, we're specifying DeepSeek 1.5 billion parameters, which is a pretty small version of it, but all that's necessary for this application. So we don't always have to use the cloud-based systems, and we can put these obviously in our own cloud and have security and not incur the cost of using the cloud-based LLMs if we don't want to. So that mainly concludes looking under the hood at the code. There are some takeaways I'd like to discuss here finally. Obviously workflows make great agentic architectures, as we've seen illustrated here. Prompt engineering, or AOP, is the next big thing. Domain-driven design becomes even more essential or imperative to do good agentic architectures. Coming soon is the Dapper agents and Sage as a productivity tool to actually build workflows out very, very quickly, even by our product people. And so we can build virtual new product lines and workflows and agentics within Allegis, of course, based on good, strong domain-driven design. And so we will be, next sessions, we'll be looking at the idea of agentic virtual actors, where agents have more independence and autonomy in talking to each other. We'll also be looking at how do you actually unit test and quality control agents as well. So that actually concludes our presentation. Once again, thank you very much. If you've got any questions, you can send me a message on Teams. I'm usually available and would enjoy chatting with you about anything that you want to know. Thank you very much.